I am going to give you some tips and tricks for Mini Project 4. So Mini Project 4 is about applications of functions, particularly a linear function. Okay, so remember, working with lines, we have an equation y equals mx plus b, or as a function, f of x is equal to mx plus b. But another way of thinking about this, especially in terms of application, is that our dependent variable is equal to the slope times our independent variable plus b. So examples, identify the independent and dependent variable. Not sure why that got cut off. So temperature versus time of day. Does temperature depend on time of day or time of day depend on temperature? Time of day is our independent variable. Okay, does our motivation depend on the week of the semester or week of the semester depend on motivation? Independent variable, motivation depends on the week of the semester. Does the season depend on the chance of rain or chance of rain depend on the season? Chance of rain, or season depends on the chance of rain. Okay, so notice if we have motivation versus week of the semester, we can draw a graph. This would be week, this would be motivation. Okay, and so usually at week 1, we're at our peak motivation, and by week 16, it fades. Okay, or maybe well, this would be a line. Okay, something like this. So notice here that when we graph this, that our independent variable is on the x-axis and our dependent variable is on the y-axis. Okay, so for example, let's take a look at how do test scores depend on time on a test. And what we're going to pull into this with our linear model is something from statistics using scatter plots, line of best fit, or linear regression. Otherwise, it's going to get us to a linear function that we can use. So let's say that we have time in minutes and our score. Does time depend on score or score depend on time? Score depends on time. So we have x, y. Okay, and in the mini project, this is all listed as one big chart, but for the sake of space here, I had to break it up into different columns. So what we can do with this is we can plot it in what's called a scatter plot, which displays the values of two numeric variables, and it can show us how variables are correlated, meaning how they're related to one another. So if you plot these on a scatter plot, so I'm going to keep in mind 7790, okay? This is what it would look like. So all the data points are here. My x-axis is my independent variable, which is time, and my y-axis is score, which is my dependent variable. Now, the way that this is formed is each of these rows, so 7790 is converted to an ordered pair, and so on and so forth. So we should have a point at 7790, which we do. It would be right here. This is 7790, and you would do that for each of those. So when you have to match a data set to a scatter plot, think of each one as an XY pair and then pick the scatter plot that matches it. Okay, so from a scatter plot, we can come up with a line of best fit. And what the line of best fit does is it estimates the relationship between two variables to be linear. So it has a predictive variable like time, okay, so, and a outcome variable like score. So with the line of best fit, it's also called a trend line. Okay, it goes through the data. And so now we have a linear regression, or what we can use as a linear model for how how test scores depend on time spent on the test. Okay, this should be negative 1.32. Okay, so this equation actually you can get from Excel or Google Sheets. You won't have to come up with it on your own. It'll be given. But grade is equal to negative 0.132 times the time spent on test plus 86.6. Okay, so our slope here is negative 0.132, or as a fraction, the 2 tenths hundred thousandths, the 2 is in the thousandths place. This is negative 132 over 1,000. The y-intercept is 86.6, okay? And then r is equal to negative 0.18. And r is just something, you won't necessarily have to know it. It's just something interesting. It's called the correlation coefficient. Okay, so for instance, if r is equal to 1, it means that all of our data points are perfectly along a straight line. So it's perfect correlation. Or if r is 0.5, we have some around the line. If r is 0, there's no correlation at all. Okay, so negative 0.5 would look like this instead, or negative 1 would look like this instead. So if you do some type of regression, R is super important to tell us how strong or not the correlation is. Okay. In any case, the focus of the project is using the line of best fit. So our line of best fit, which is a linear equation. Okay, so what would you expect a student's score to be if they spent 57 minutes on the test? Round your answer to the 10th place. So in this case, 57 minutes is our time spent on the test. Okay, so we would have our grade is equal to negative 0.132 times our time plus 86.6. Okay, so if we plug this in, we would have negative 0.132 times 57 plus 86.6, which gives us 79.076. We're asked to round to the 10th place. Okay, the 10th place is the place immediately to the right of the decimal. It's a 0. We look next door. Since the number next door is 5 or greater, this becomes 79.1. So using this, it's kind of what I said, time is our predictive variable, grade is our outcome. So we're predicting that if a student, based on this model, that if a student spends 57 minutes on the test, they would earn a grade of 79.1. Okay. Question 2, if a student wants to score 80 on the test, how many minutes should they spend on the test? So 80 is our grade, and now we're solving for x, or time, okay? And we solve this just like we would any other linear equation. So we subtract 86.6 from both sides, and we get negative 6.6 is equal to negative 0.132 times time. And then we divide by negative 0.132. Okay. And we get 50. Okay, so if we want the outcome to be an 80, then we need our time to be 50 minutes based on this model. Next, according to the line of best fit, what would a student score if they spent 0 minutes on the test? So this is really asking us to read the y-intercept. Okay, or you can plug in 0 for t, but this would be an 86.6. Okay, and then how do you interpret the slope? So our slope is negative 0.132. Remember, our slope is our change in dependent variable over independent variable. So the units here are grade per minute. Okay, so what this is meaning is that for each minute that is spent on the test, the grade goes down by 0.132. Okay. Next, so there's limitations of the model. So for instance, on this particular test, the time allotted was between 0 and 85 minutes. Okay, so that would be like our domain. Our range, our scores can range from 0 to 85, but we would have to plug in our values in the domain to see if that's really what we're looking at here with this test. Okay, so there are limitations to any application problems, and also determining if it's realistic. Like, is it realistic that spending no minutes on a test would earn a score of 86.6? No. Okay, so think about that as you're doing these models. If you have any questions, let me know.